In this recording, I'd like to go over methodologies for analyzing returns on investments. So typically, investors or senior management, company owners will use it to assess if a project they would like to invest in, is it worth pursuing or not. And it could be investing in a new product, could be or expansion of a product, could be investing for productivity or efficiency, let's say in a factory to put automation, investment to replace equipment, old equipment versus bringing in more efficient new equipment, and or if there are more than one projects and company can invest in only one or two, this methodology will help them decide which one. So investment analysis methods typically fall into two types of basic methods. One would be in terms of assessing how long before the investment is recovered, and that is basically saying what is a payback period in terms of time, how many years, how many months, so on. Another flavor or version of payback is called discounted payback. Again, it is still how long, it's going to be years and months. But the difference between the discounted payback and the payback is that in the discounted payback, we would account for the time value of money, and hence we will discount the cash flow, which is basically another way of saying we will calculate the present value of the future cash flow. The second category is acceptable return, and there are two methodologies that are used. One is called the net present value, NPV, and the other one is internal rate of return, IRR. In the presentation, I am going to go through all four of these one at a time. So starting with the payback. A payback is the number of years required to recover a project's cost. How long does it take to get our money back? We invest money up front, we are in a hole, or we are a negative cash flow. And as the project proceeds and as we achieve the returns we want in terms of new product or expansion or efficiency, and we will have positive cash flow. And as we collect positive cash flow in the out years, in the future years, it will offset the investments we have made, and eventually we would have collected enough positive cash flow to offset the investment, and then that is the amount of time it takes to do that is called the payback. So how do we do it? Let's say we have a project that we spent 100, and that's why the first number is minus 100, because we are investing our money, so there is a cash leaving us, so it's going to be a negative. And let's say this project in year 1 provides a positive cash flow of 10, year 2 positive cash flow 60, and year 3 positive cash flow for 80. So to figure out how long does it take to recover this 100,000, we start with minus 100, we add the 10, which is in year 1, which is positive. So by the end of year 1, we are still negative minus 90. Year 2, we add 60, so by the end of year 2, we are at minus 30, so we're still in a hole. So we know it will take at least 2 full years and a portion of the third year. To figure out what portion of the third year we will need, we will take the minus 30, and we need 30 out of the 80 from the next year, so we do 30 divided by 80. So the payback period for this example is 2.375 years. Now, in the case of a discounted payback, we add one additional step in the process. The step we add is we calculate the present value, which is saying the same thing as discounted value, the discounted cash flow for each year. And once we have the discounted cash flow, then we do the payback calculations, just like we did with the other payback. So again, as a reminder, present value is a calculation of future value. So let's say we had $100 in year 3. Formula, as we know, for time value of money is the present value is future value divided by 1 plus R. There should be an R in the parentheses. raised to year 3, and the number would be 7513. So if we take the example we just did, and now we are adding an additional step, which is the present value of the cash flow, which is the second row. So we do the calculation, we take each of the years, we divide it by 1 plus r raised to n. N is, year. So for example, year 1, the cash flow was 10. We would divide that by 1 plus r. In this case, we're using a 10% discount rate. So it would be 1 plus 0.1 raised to 1, and that will give us a 9.09. Second year, 60 divided by 1 plus 1 raised to 2, we get 49.59, and third year would be 60.11. And after that, we do the same way. We start with minus 100, we add 9.09, so we are left with 90.91, and continue to so on. So we see that in this case, the payback period will be a little bit longer. It's going to be 2.7. And the reason, as you'd expect, because we are discounting the future cash flow or the present value, which is going to be less because of the time value. Using this methodology, the payback period will be longer. So the question is, if we are going to use a payback period, which one would we use? The answer is, if it is a very, very short period project, something that we know is going to recover within a year or so, then the time value effect is very small. But if you have longer term projects, then you know that the future value will be worth a lot less, because we have n is going to be a high number, and hence in that case you should be using discounted payback period. Okay. Next one is called the net present value methodology. And here what we are going to use is, again, we are going to use time value of money, but now we are going to use a methodology called net present value. And the methodology is that we calculate the net present value. Basically that means is we calculate the present value for all the cash flow, we add it up, and that's why it's called net. Once we add it up, and if the value is positive, that is, if it is greater than 0, that means that we have achieved our hurdle rate or the discount rate. If more than one project, obviously we will pick the one that has got the best NPV. So let's do an example. Now, before I do the example, let me show you the formula that is used. This formula may seem a little overwhelming, but this is really nothing more than time value of money that you already know. The CF is nomenclature for cash flows. The CF0 is a cash flow in year 0, CF1 is a cash flow in year 1, and so on. And we're dividing by, again, 1 plus r raised to n. And the little Greek sign basically means that we are now adding it all up, so it's sum of all the cash flow. And again, if the NPV is positive, the project is acceptable. So let's see how the calculation will work. So here is a project which had these numbers, okay? So if I want to know what the net present value is for this project, I would basically calculate the present value for each one of them. And again, how do we do that? We take the cash flow for that year, we divide it by 1 plus r raised to n, and we get these numbers, and if you add them up, we get net present value. So now we apply this to the example we did using for payback, which was again minus 100 in year 0, 10, 60, and 80 are the future positive cash flow. If we calculate the net present value for each one of them, which are shown vertically on the bottom, it would be minus 100, then 9.09, 49.59, 60.11. If I add them all up, we will end up with 18.79. And basically I'm summing minus 100 with these positive numbers, the 9.09, 49.59, 60.11. So in this case, the net present value, which is really nothing more than summing all the present values, the negative one, which is year 1, or year 0, and all the other positive one. The net present value for this project is 18.79. So in this case, based on the criteria that if the NPV is positive, then this project will be acceptable. Now, The last one is internal rate of return. And again, this is applying present value methodology, the time value methodology. And here, IRR is the discount rate that forces the present value of inflows equal to cost and the NPV equal to 0. I will take a pause and make a comment. As you're listening to this stuff, it may seem a bit overwhelming. But don't give up yet. When I show you the example, you will see it is really not that complicated. So let me explain to you the methods and the formula, and then I will show you how to do it on Excel. So again, this requires a trial and error, and changing the R till the NPV is 0 or close to 0, and basically, we are taking the NPV formula that we had used, and what we are doing in this case, and again, Excel does it for us, but what the process is that we change the R that is in the parenthesis in the bottom, and we keep changing the R till the NPV on the right side of the equal sign basically becomes 0. And so if you do that, the R basically is the IRR. And so Excel calculates it for us, but basically what Excel is doing is keep changing the R till you get to the point where the NPV is equal to 0, which means that the cash flow in CF0, which is the year we are investing the money, which is typically negative, will be equal to the present value of all the cash flows on the other side of the equal sign, and that R is called the IRR. So let's take the example we have been using. So we did the NPV calculation, as you recall. Again, I'm showing you this slide again from one I had shown you earlier. With the discount or the hurdle rate of 10%, you see on the bottom right corner, we came up with the NPV of 18.79. Now, if we go in and change the R from, say, 10 to 12%, what's going to happen is that if I go back here, what is going to happen is, as you notice, as the R is in the denominator for all the fractions. So if I make the R bigger, instead of being 0.1, which is 10%, if I make it, say, 0.12, which is 12%, the denominator is getting bigger. If the denominator is going to get bigger, obviously the CF1 divided by 1 plus R will now become smaller for 12% compared to what it was for 10%. If I make it 14%, it's going to make the denominator even bigger. So the overall fraction will become smaller. So you keep increasing the R, all these numbers get smaller. So by trial and error, we can find the R for which the NPV will be 0. So if I do that for our example, if I start with 10% of discount rate or the hurdle rate, our NPV is 18.79. If I go in and do the calculation again, but use 12%, my NPV will drop to 13.7. So as I continue, at about 18.1% R, the NPV is 0. This 18.1% is called internal